Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the May-June 2004 Mechanics M1 paper from Cambridge 9709. This is the International A-Level. Very old question, very old paper. And this question is about vectors and resultant forces. Okay, so I put it under my forces and friction chapter of my end of topic worksheet, and that's where I've taken it from. That's the way a student has asked me the question from. It's question number 1 in my end of topic worksheet for forces and friction from my M1 collection for Cambridge. So it says coplanar forces of magnitudes 250, 100 and 300 newtons act at a point in the direction shown in the diagram. So coplanar means that this is like they're acting in just like 2 dimensions. It's not 3 dimensional. Okay, it's like if there was a flat surface, they'll be acting, on that flat surface. They're not going to be, 3 dimensional, going out in different directions, just in 2 dimensions, like on a horizontal surface, you could say. So they are shown in the diagram. The resultant of the 3 forces has a magnitude r newtons and acts at an angle of alpha degrees anti-clockwise from the force of magnitude 100 newtons. So the resultant force is going to act something like this, in this direction. Okay, so the resultant force will be somewhere in that direction, anti-clockwise from the 100 newtons force at an angle of alpha from it, something like this. The angle would be alpha. Okay, so that's the resultant force. All right. Find R and alpha. Okay, so I'm going to just draw this diagram down here again because I don't want to get a headache, keep on scrolling up and down all the time. Okay, so basically I'm just going to draw this same diagram over here. This is the resultant force acting at an angle of alpha from anti-clockwise from the 100 Newton force. This is alpha. This is the resultant force. Okay, so to deal with this question, because there are 3 forces that cause this resultant force, I can't use a vector triangle. Okay, which you could, if there was just 2 forces acting, then it's easy to use a vector triangle, draw 2 of the forces, and the 3rd force will be the 3rd side of the triangle, and then you can use the sine rule. However, in this case, because there's 3 forces acting, okay, you can't do that. You'll end up with 4 sides. Okay, if there's 3 forces and the resultant is 0, if it's in equilibrium, you can do that. But if there's 3 forces and it's not in equilibrium, you can't do that. Okay, unless you do something which is a bit more complicated. So what we can do here, the easy way of dealing with this is, let's think about what the resultant of these forces are horizontally, and let's think about what the resultant of these 3 forces are vertically. And then we can find the actual resultant force, okay, from those 2. So the resultant of these forces horizontally, well, the 300 newtons has no effect horizontally, but the 100 newtons force has a component. Well, it is horizontal, so it's just 100. But the 250 newtons force, you have to resolve it horizontally, so it has to go through the angle given. So it's going to be plus 250 times cosine of 70. Okay, because when you want to resolve a force in the direction of, if you want to resolve the force in a direction, like I want to resolve this force in this direction. I'll put this in a different color so it's distinct from the resultant force. Okay, so I want to resolve this force in this direction. Okay, I have to go through the angle given. So that is going to be 250 times cosine 70. 250 times cosine of 70. And if I want to resolve the same force, okay, in a direction which is vertical. Okay, I want to resolve this force vertically. Okay, then I have to go away from the angle given. So it's going to be sine. Okay, this way is going to be sine going away from the angle 70 there. So I'm going to use sine. Okay, you can think of that as this side being the opposite to the angle, so that this is parallel to that side. That's going to be 250 times the sine of 70. Okay, so those are the horizontal forces acting on this particle, and the vertical forces. So I've used right as positive here, and here I'm going to use up as positive. So the vertical forces acting on this are going to be 300 minus 250 times the sine of 70. Okay, so those are the resultant forces. Okay, those are the components of the resultant force. So if I want to find what the actual resultant force is, I can draw the horizontal and vertical components of this force. Okay, so I can, for example, here, I can draw the horizontal component. Okay, so I'm going to draw that first as a vector. So I'm going to have, that's a horizontal component. Okay, and this is the vertical component. All right, so horizontal and vertical components of the force. So this is RH. And this is RV, and our resultant force is basically this. Okay, this is the resultant force. This is what we have to find, and this is the angle we have to find. Okay, so we need to find this resultant force, and we need to find this angle, and we know what these two are. We know the value of these two. Those are those. So if I want to find the angle, okay, well, let's say I want to find R. R is going to be the square root of the square of RH plus the square of RV. Okay. RV all squared. Okay, that's going to be our resultant force. So we have both those values here. Okay, so we can say that's going to be equal to the square root of, you have 100, I'm going to keep it in exact form. So this would be 100 plus 250 cosine 70 all squared. All of that squared. Plus, we're going to have this, which is 300 minus 250 sine 70 all squared. So that's going to give us our value of R. So I can just stick this in the calculator and get the answer. So I have the square root of, let's put it over here, let's see what's going on. So the square root of, we have in brackets 100 plus 250 cosine 70, and we should be in degree mode. Are we in degree mode? I don't think so. So we just do that now before we forget. To angle unit, we have to be in degree mode, which is 1. Now in degree mode, for sure. Okay, and then we got to plus, we got to add to this in brackets. Oh, we forgot to square it. 1 second. Okay, so we got bracket, another bracket we need, and squared. Okay, and then we're going to do plus in brackets. We have 300 minus 250 sine 70. Bracket for the angle, bracket for the bracket, squared. Okay, so this should give us our answer. Good, it didn't say syntax error. All right, good. So that's 196.588. 196.588. So we can round our answer to 3SF. That's going to be 197 newtons. And to find alpha, we can use simply that the tan of alpha equals RV over RH. Okay, so I can just put that here. So alpha is inverse tan of RV, which is 300 minus 250 times the sine of 70 divided by RH, which is 100 plus 250 times the cosine of 70. Okay, so that should give you your angle. So alpha is equal to, so now we're going to do inverse tan of 300 minus 250 times sine 70 divided by 100 plus 250 times cosine of 70. And that will give us an angle, hopefully, in degrees. Oh, this time I got syntax. What did I do wrong here? Let's have a look quickly. Inverse tan 300 minus 250 sine 70. I forgot the bracket on top here. No, what I've done is this bracket here. Sorry about that. Should be a big bracket at the end. This should work now. Yes, it does. So that's 19.331. So you get 19.331, which is 19.3 degrees to 1 decimal place, which is how you should round it. So this is R and this is alpha. Alpha is equal to 19.3. So those are our two answers. Okay, so alpha is 19.3 above the horizontal basically, and that's 197. So that concludes this question, which is question number 1 from the paper, May, June 2004. Question number 2 from my worksheet. You want to see other questions from this paper? Well, if I've answered any, you'll find them in the playlist, which will be appearing on the top right of the screen at the end of this video. You want to see other questions from this worksheet? You'll see the playlist for that in the bottom right of the screen. You want to see other questions dealing with forces and friction and the vector kind of questions, then you can click on the link which will show over here, and you can subscribe to the channel by clicking on the link above. Thank you for watching and see you soon.